See, today what we are going to look at an interesting concept. It normally, I mean, I got introduced to it only in 11th standard. Okay, so it is a maybe in school, I don't know now in CERT and all, maybe they might be teaching earlier in 9th or something, I don't know. But and you guys are mostly 5th, 6th, 7th, 8th, etc. Right? So maybe many of you would not have got it, but I think it is easy. I mean, you have got the mathematical grasp that you will be able to understand it. Once you understand the grasp, then it is a very powerful concept. Logarithms last week I mentioned to you, so I'm going to explain that to you. And let us see. Anybody, Madhura, you are probably in the highest standard, 9th, right? You are. So is logarithms there in the thing or
no,
not?
we haven't learned it yet.
Sorry.
No, not yet.
Not yet, right? Yeah. Okay, fine. That is okay. So see the concept and why I am covering it is that it is in line with our thing. We are teaching here not maths or school maths, but mathematical thinking and how mathematical insights helps us solve problem, right? So logarithms is absolutely in line with that. So let us understand it conceptually. Okay. So let me take a whiteboard. Yeah, let me know. You can see the whiteboard, right?
Yes, sir.
Right. Okay. So let us start with a very simple this one. Okay. We know the power series 2 raised to 1 is equal to 2. We'll just put this here so that it is there for reference. 2 raised to 2 is equal to 4. 2 raised to 3 is equal to 8. 2 raised to 4 is equal to 16. 2 raised to 5 is equal to 32. 2 raised to, I will do up to 10 and then we will see. 6 is equal to 64. 2 raised to 7 is equal to 128. 2 raised to 8 is equal to 256. 2 raised to 9 is equal to 512 and 2 raised to 10 is equal to 1024. Okay, so all of us, we know this, right? This is the power series, right? Yes. And so and that same thing is equal to, so it is equal to 2 itself, and you can also express it as 2 multiplied by 2. This is how they teach you the powers, right? 2 multiplied by 2 is equal to 2 multiplied by 2 multiplied by 2 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 2. So how many, that is how the power, right? 2 raised to 5 means you multiply 2 by itself 5 times, right? All of us know this?
Yes, sir.
Yes, sir.
This is how we understand it, right? I mean, I will not write it here, it becomes too much. So it is too much to type, but you get the idea, right? So all of you get the idea. Now, do you also get the idea that 2 raised to any number, I will give a variable name, okay? I'll not tell exactly what is the number. 2 raised to a, okay, multiplied by 2 raised to some other number b, okay? I will say this is same as writing as 2 raised to a plus b, okay? Now you substitute a and b any numbers between 1 and 10. Actually, you can substitute absolutely any number, but just for simplicity's sake, I have put it. So let us see if everybody accepts that this is true. Okay, so but we don't have to accept it as it is. Okay, we will first see whether it is. We'll just do 3 examples and we'll see. So Ashish, choose any values for a and b between 1 and 10. Ashish, just speak out any value. Hello, you are on mute. Yeah, Ashish. Hello.
Sir, I had a question.
Yeah.
So doesn't this just mean it's like the distributive law, but instead of multiplication is power.
Yeah, but because it is at the power, right? So it is at the thing. Yeah, it is like distributive law. But yeah, but Ashish, you are right, Ashish, and we'll come to that. Ashish, are you there? Can you hear me? Okay, I don't know what is. Maybe Ashish has some this one. Shreyas, do you want to go and choose any values A and B between 1 and 10?
Yes, sir.
Okay, say out.
So for A, I will choose 3.
Okay,
And for B,
A is equal to 3 and B is equal to
8.
B is equal to 8. Fine. Okay, now what does 2 raised to A is 2 raised to 3. Okay, multiplied by 2 raised to 8. Okay, this is same as 8 multiplied by 2 raised to 8 is 256. Correct? 2 raised to 3 is 8. 2 raised to 8 is 256. Right? Now, this is same as what is this? 256 into 2 is 512, into 2 is 1024. But so it is 2 into 1024. Correct? Okay.
Yes.
Right? Or you can, I mean, this is one step I have gone here. 2 into 4 into 256. Now 4 into 256 is nothing but 1024. So this is equal to 2 into 1024, and this is nothing but 2 raised to 11. Because why will you put 2 raised to 11? 2 raised to 11 is 2 into 2 raised to 10. Correct? Shreyas, you are following me?
Yes, sir.
Right? So it always happens, and why it happens is because of this rule. See, when you are saying that 2 raised to 3 into 2 raised to 8, what you are essentially going is you are saying 2 raised to 3 is this number multiplied by 2 raised to 8, which is nothing but 2 star 2 star 2 star 2 star 1 2 3 4 5 6 7 8. Yeah, correct. And this number is nothing but 11 times 2, right? Because here there is 3 and here is 8, right? So this is nothing but 2 raised to 11, and that is nothing but 2 raised to 3 plus 8. Correct? So this is true for any number. Okay, any A and any B you choose it, this thing holds. 2 raised to A into 2 raised to B is nothing but 2 raised to A plus B. Ahan, you got this much? Do you agree with this? Or there is a doubt? Come on, speak up, guys. If it is not clear, you have to tell that it is not clear.
Sir, I don't understand.
Huh?
I didn't understand.
You didn't understand? Let us go through it again. See, what we are saying is, see, first of all, what we are saying is 2 raised to 3. What does it mean? You write it as 2 multiplied by 2 multiplied by 2, 3 times. Correct?
Yes, sir.
Right? 2 raised to 5. What does it mean? You multiply 2 by itself 5 times. 5 times. Right? Now, what we are saying is 2 raised to A. What does this mean? You multiply 2 by itself till you reach A times. Okay, A is some variable. Variable means it can take any value, right? At a given point of time. So what we are saying is, let Shreyas chose A is equal to 3. What does that mean? 2 raised to A is like 2 raised to 3, which is 2 multiplied by 2 multiplied by 2. Correct?
Yes, sir.
Yeah. And the other number, 2 raised to B. 2 raised to B is nothing but 2 multiplied by itself B times. Right? So what do you express it as? B is equal to 8 here, Shreyas chose. So you multiply 2 by itself 8 times. Correct?
Yes.
Right? Now you multiply both these numbers together, which is 8, 2 raised to A and 2 raised to B. Then what you will get is that 2 multiplied by itself so many times. And what is that 8? It will be exactly A plus B times. Because left side you are having 2 multiplied by itself A times. Right? And then here multiplied by here again you are having it multiplied by itself B times. So, and it is all 2 only. 2 into 2 into 2. So what do you get it? So together you will get it multiplied by A plus B times. Right?
Yes, sir.
I mean, we can do this simple. We can do this by simply, let us take smaller values of A and B. So 2 multiply, let 2 multiplied by 2, which is a is equal to 2, and this multiplied by 2 raised to, okay, I will put this first. 2 raised to 2 multiplied by 2 raised to 3. What does this mean? 2 raised to 2 is 2 into 2, and multiplied by 2 raised to 3 is 2 into 2 into 2. Correct? So this is nothing but 2 into 2 into 2 into 2 into 2. Correct? And this is nothing but 2 raised to 5. And so 2 raised to 2 plus into 2 raised to 3 is nothing but 2 raised to 2 plus 3. So these numbers get added, whatever is the power. Okay, does it make sense now?
Yes, sir.
Right? Ahan, everybody gets this?
Yes, sir.
Okay. So this is the first law of powers. Okay, it is first law of powers. Now you also have another law, and let me see if you can guess it. Division. Yeah. Sorry, Madhura, you were saying something?
Yeah. Sorry, all this we learned last year. So are these logarithms?
What is that? Sorry.
We learned all these laws and all last year. No, I guess in 7th we learned this.
You
Yeah.
7th you learned, right? Yeah. But
Yeah.
correct. So
So
I'm
are these logarithms?
no, these are not logarithms. These are preparation for logarithms. I'm going to tell you. Okay. So this because there are also people from 5th and 6th standard, right? So they would not have known this. So I'm just making this base concept clear first.
Yeah.
Okay. Now there is another law which is division law. So let us take 2 raised to a divided by 2 raised to b. Now just by analogy you might be able to guess what should be the answer. Madhura will know this, but others, can you guess it? What will be the answer? If multiplication becomes a plus b, then division becomes
minus.
correct. A minus b it becomes. This is the law. Okay. This is the law, and we'll see it. Let a is equal to 3 and b is equal to 2. Then 2 raised to a is equal to 3. We'll just try it out for 2 examples. A is equal to 3 and b is equal to 2. Then what does this mean? 2 raised to 3 divided by 2 raised to 2. This is equal to 2 into 2 into 2 divided by 2 into 2. Now, sorry, 2 into 2. So now the 2 into 2, 2 of them will cancel each other out. What will be left is just 2, right? Which is equal to 2 raised to 1, which is equal to 2 raised to 3 minus 2. And you follow this much? Everybody followed this? We said 2 raised to a divided by 2 raised to b. And we just took some example values. A is equal to 3, b is equal to 2. Yeah, somebody was saying something. Does this look okay or this looks doubtful? Wrong. Come on. Yes or no?
No, sir.
No? So let us start. 2 raised to a. We want to see what happens when you divide 2 raised to a by 2 raised to b. Okay. And can we simply write it as 2 raised to a minus b? This is what I'm saying. Now let us take an example. Let a is equal to 3. Okay. What does that a is equal to 3 mean? 2 raised to 3 is the numerator, right? 2 raised to 3 is the numerator because a is equal to 3, and denominator is, let b is equal to 2. So it is 2 raised to 2. Now what does 2 raised to 3 in the numerator means? It is 2 multiplied by 2, correct? This much should be okay, right? This is the numerator, 2 raised to 3. Yes or no?
Yes, sir.
Right? And denominator is 2 raised to 2. What does 2 raised to 2 means? It is 2 into 2. Right? Now 2 into 2 into 2 divided by 2 into 2. The two pairs of 2 on the numerator and denominator will cancel each other out, and you will be left with only 2. Answer is 2. Right? Because 2 raised to 3 is 8, 2 raised to 2 is 4, 8 divided by 4 is 2. All of you know it, right?
Yes, sir.
Right now, but what does this tell? What does this tell you is that, I mean, why this formula is powerful is let A and B can be any number. It is not the 3 and 2. It can be any number. Let, for example, let A is equal to 9 and B is equal to 6. Now, now I tell you to calculate 2 raised to 9 divided by 2 raised to 6. Now, it is a very simple way you can calculate, because you know that 2 raised to 9 is 2 multiplied by itself 9 times, and divider is 2 raised to 6, which is 2 multiplied by 2 itself 6 times. When you take the numerator divided by numerator, that 6 times 2 will cancel each other out, correct? Because both of them, the numerator has 2 multiplied by itself 9 times, denominator has 2 multiplied by itself 6 times. So what will happen? 6 times will cancel each other from the numerator, and what you will be left with is 2 raised to 3. It's a very easy shortcut to get the right answer. Are you following me?
Sir, yes, sir. Sir, but I had one more question.
Yeah.
I understood this, but to use this, we need to figure out how to do a square root, right?
So I, step by step, I will come back. So that is where the logarithms come in. You don't need to know square root. Okay. So we are just getting it. First, you get this idea right, that 2 raised to A multiplied by 2 raised to B is equal to 2 raised to A plus B. Okay. Now, and the similar way, 2 raised to A divided by 2 raised to B is equal to 2 raised to A minus B. This much you get it. If you get it, then we'll go to the next step and I'll make it. So it will take, today's class will last for about an hour. So we'll have to join back, because till I come to the logical thing. But I want you to know each step perfectly well. So is everybody getting this?
Yes.
Because this is nothing but 2 multiplied by 2 multiplied by 2 multiplied by 2. This much is the numerator divided by 2 multiplied 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 by 2, 6 times. Numerator is 9 times, denominator is 6 times. That 6 times will cancel each other out, because it is exactly same number on the numerator and denominator. So what you will be left with, only numerator will be left with 3 times. 6 times will cancel each other out. So that is nothing but saying that there is numerator has got 9 times repetition, denominator has got 6 times repetition. 6 times is cancelling out. So from 9, 6 cancel out. So what is left with is 3, which is nothing but you saying that it is 9 minus 6 is equal to 3. Okay. Do you get this? Does this make sense?
Yeah.
Right? Everybody, I wanted to know this very clearly. If you know this, and now, and you don't have to. So now what I have said is that this formula, you don't believe that just Shivaji sir is saying that's why it is okay. No, you are seeing it with examples, and now with understanding also that this formula works. Right? This formula works. Right? The additive formula and the subtractive formula, both of them work. Now, it is interesting. Now, the next step we are going to. Okay, I'm going to clean this whiteboard up. Are you anybody still has any questions, or I'll clean it up? Okay, I guess everything is okay, right? I'm going to erase it. Okay, last chance. 1, 2, 3. Okay, let me erase this. Now now the next step is that all of this we did it by raising the power of 2, right? 2 raised to A, 2 raised to B. What if it is not 2? What if it is 3? 3 raised to A, 3 raised to B. Does the law still hold?
Yes, sir.
It holds. You are right. So it is not just about 2. It is about any number. So even if you take 3 raised to A multiplied by 3 raised to B, as long as it is the common, 3 is common, then you will be able to write it as 3 raised to A plus B. Okay, because 3 raised to A is nothing but 3 multiplied by itself A times. 3 raised to B is 3 multiplied by itself B times. When you multiply them together, how many times they are there? They are there multiply A plus B times, and that is why it is same as 3 raised to A plus B. Okay, so it is 2. There is nothing. It is not special about 2. That is the property of the powers. Okay, it does not matter whether it is 2 raised to something, 3 raised to something, 8 raised to something, or 10 raised to something. As long as And similarly, 3 raised to a divided by 3 raised to b is same as 3 raised to what? A, what is it?
A minus B.
Minus B.
Correct. And it is same thing with 4, same thing with 5, same thing with 6, all the way to same thing with 10. 10 raised to a into 10 raised to b
So,
equal to 10 raised to a plus b.
so,
Yeah.
so this is for multiplication and division, but if we do 3 raised to a plus 3 raised to b, then
Then it is different. Addition ke liye it is not. There is no simple formula like that. Because it is for multiplication, it is the thing. Addition ke liye, there is no way you can just directly get it from that. But I will tell you why it is still useful. Okay. Most of the time, adding two numbers, you don't have any problem. It is a very simple way to add or subtract two numbers. But multiplication and division of large numbers takes time, cumbersome, and is difficult, right? Especially, I will come to the next thing actually. So, so 10 raised to b. So let me just write this. So you are many times in maths or whatever, when you are doing calculations, addition and subtraction hardly ever is a problem. You can always, given 32 digit numbers also you give, and you ask me to add two 32 digit numbers. We said that we have a simple algorithm for adding digit by digit, carry forward. Within 1 minute or 2 minutes, you will be able to do the addition of even 32 digit numbers, right? But you ask me to do even 5 digit number multiplied by a 7 digit number, it takes a lot of time, right? And now you have calculators, but what is the, I mean, we are thinking about the mind here, how we should be able to do it, not with the help of a calculator ourselves, right? So it takes time to do the thing, right? Now I will come to the, okay. So now, first of all, let us go. Now this much you have understood everything. This is okay. 10 raised to a into 10 raised to b is 10 raised to a plus b. And 10 raised to a divided by 10 raised to b is 10 raised to a minus b, right? Okay. Avanish has given me a thumbs up. I hope everybody has. Ahan, you are also with me? Ashish? Madhura has given thumbs up. Okay. Ashish also gave. Okay, good. Pranav has also, I hope. Sai Pranav, I'm sure. I hope everyone, right? Okay, fine. Good. I'm sure. Okay. Now there is another way of something. What is the way the logarithm is defined, right? Logarithm, now I will take a thing, and logarithm is defined as like this. If 10 raised to a is equal to some number n, some number, it will be some number, right? It will be whatever, 10 raised to 2, 3, 4, 5, 6, whatever you will get some number, right? Okay. Then logarithm to the base 10, logarithm of that number for base 10. How do I write? Subscript I have to write. I can't write it. So log base 10 of that number is equal to a. This is what it means. Logarithm means, if let n be some number which is written as 10 raised to a, okay, 10 raised to a, then logarithm to the base 10 of that number is nothing but a. Okay. Similarly, if let some number m is equal to 2 raised to x, okay, let it be written as, let it be the xth power of 2, then what it means is log to the base 2 of m is nothing but x. This is what the logarithm is. Okay, now most of the time we don't write it because we consider the base is always 10, because we are using the decimal system, right? All of us are using the decimal system. In computers we use a binary system. So hence while this is the general rule, most of the time we always take the best base to be 10. Okay, just as we take the digits, 10 digits decimal, we use it. So we take implicit that base is 10. Then we say that if let n be any number which is 10 raised to x, which is same as saying as log, and now we don't say base 10 because it is considered as given. Always it is base 10 only. Log of n is equal to x. This is what it means. So when this is what is the definition. It is like the inverse of the power. Okay, 10 raised to x is n, then log of n is x, and log of n is log of n to the base 10. This is by definition. This is how the logarithm is defined. Okay, it is nothing but inverse way, because you can write n is as a power of 10. Then you can also write whatever is that number x, that x number you can write is as a logarithm of n. Madhura, is this definition you are getting it?
No, sir. Can you explain again?
Okay. So let some number n, let it be equal to 10 raised to x. Okay, 10 raised to x, you right? 10 raised to x is like 10 raised to 1 is 10, 10 raised to 2 is 100, 10 raised to 3 is 1000. So okay, so let some number n be such that it is 10 raised to x. Okay, then what we say is log of n, we say is equal to x. So if n is equal to 1000, if n is equal to 1000, then we say log of 1000 is equal to 3. If n is equal to 100, then log of 100 is equal to 2. Okay,
so the other way around.
yeah, it's the other way around. It is just the way of putting it. So I hope. Okay.
Sir,
And
I didn't understand that log n equal to x.
no, so it is just a way of expressing it. See, you can express it as 10 raised to something. See, it is like this. We consider 10 as the base. Some number is n is there, which is 10 raised to x. Okay, so we can write n is equal to 10 raised to x, right? N is 10 raised to x. Now, if you want to ask what is x, then x can be written as log of n. If n is equal to 10 raised to x, then x is equal to log of n. And the other way around. If log of n is equal to x, then n is equal to 10 raised to x. It is just a way of writing or see how. So given this one, right, n is equal to 10 raised to x. Now I can ask you what is x. So given n, you can find x, and given x, you can find n, because 10 is fixed. Does it make sense?
Yes.
Right? I will take another way. Okay, I will.
So,
And
sir, if like you've written if n equal to 1000, log 1000 equal to 3, no, sir?
yes, log of 1000.
For that, like 10, it will be if n equal to 10, log 10 equal to 1, sir.
Correct. Absolutely, you are right. You are right. Log 10 is equal to 1. Because,
Sir, can you repeat it again, please?
okay. Let us go it. See, it is.
Sir, it's going reverse.
Yeah, it is going reverse. That is what. See, it is. That's what. See, let some number n be written as 10 raised to x. Okay. And we took an example. N is equal to 1000. Now 1000 is equal to 10 raised to x. Then what is x? See, 1000 is 10 raised to 3. So if 1000 is equal to 10 raised to x, then x is equal to 3. Correct?
Yes, sir.
Right, so that is nothing but, so that is the log is nothing but writing this reverse thing. If n is equal to 10 raised to x, then log of n means x. That is the way, or the other way around. If someone writes to you, someone gives you, oh, I am giving you log of some number n. Okay, I am giving you. Now you find out what is the number. So this is given. So given log of n, suppose some value. If I give you the value of log n. Can you find out what is n? I'm giving you log n. Okay, which means that I'm telling you 3. I'm telling you log of my number is 3. Then what is the number? Then you will say number is nothing but 10 raised to whatever is the whatever is the thing. So
So this is log base 10 3.
yes, it is base 10 because we are just choosing base 10 because it is common for us. If I give you log n, whatever some value I give you, let us say it is 3. Then what is n? Then n is equal to 10 raised to whatever I give you, log of n. Because if I give you log of n as 3, then what is n? N is 10 raised to 3, which is 1000.
Okay, sir.
So, but it's always 10.
No, okay. So this is where you put it. It is actually not always 10, but most of the time we assume that it is 10, and that is where, unless you specifically say that, oh, I'm using a different base. It is like, for example, saying that if I'm telling you what is this value, okay, 12. Now you assume that I'm telling decimal, and hence the value is actually 10 plus 2. Okay, but if you were to use that earlier system when we had used octal or some trinary system, then the what is written as 12, actually it might be value might be 5. In a trinary system, value is actually 5. 3 into 1 plus 2 is equal to 5. But we know that in our normal things, unless we specify, we always deal with decimal system. Correct? Correct now? Unless we if we are telling about binary, then we will tell, oh, this problem is in binary. Okay, then we will tell that this number is written in binary form, and hence the value, because or take the value 1 0. In binary, the value, why no, you know, the value in binary, this is equal to 2. But in decimal, it is equal to 10. Correct? We had seen it. I hope you remember the decimal and binary notation. So just as we always assume that we are dealing with this decimal system, unless specified. Similarly, in logarithms also, unless specified, we always deal with the base as 10. Okay. Okay. So So it is just, that's why, I mean, this concept, you get it. Once you get this right, then everything else will be the next, there is 2 more steps to understand, but it will be very, very thing. What is there on the chat? Let me see. Okay, it is clear. Okay. So what essentially it is saying is that, okay, and it is same for the other bases also. Only thing is that for simplicity, we are dealing with log 10. Okay, base 10. So if I tell you that if log of my number is 4, I'm telling you log of my number, of some number x is equal to 4. Can you find out what is that number x?
Yeah, sir, whatever with the power 4.
Correct.
10 is to 4.
10,000.
10,000. Okay. So this concept, if you get it now, then the next concept is very, very interesting, because it is very powerful. It is more than interesting. It is very powerful. That's why. So I hope this much is okay. Everybody is okay. Shreyas, Ashish,
Yes, sir.
Pranav, yes.
Yes.
Okay. Avnish, Sai Pranav, Ahan, everybody. Okay. So this is okay. See, if log of x is something, then x is 10 raised to that something, whatever something I had given. Okay.
Yes, sir.
Okay. Fine. So now I will erase this. Okay. I think I will probably require one more session beyond today to explain, but it is okay because this concept is like this, right? So, which is fine. So now, interesting, till now we were dealing with only whole numbers, whether it is for the base, whether it is for the exponent, power a raised to b or whatever, 10 raised to 2, 10 raised to 3, 2 raised to 3, 2 raised to 5, everything, both sides were whole numbers, right? Okay. But mathematicians have found a way of calculating powers even for fractions or point numbers, which right now you just assume that there is a way to calculate it and it is there. So what it means is that it is not that I just can take 2 raised to 2 or 2 raised to 3 or 2 raised to 5 or whatever, you can also write 2 raised to 1.5. Now, we don't have an easy way of what does 2 raised to 1.5 mean, right? Because you cannot multiply 2 by itself 1.5 times. You can either multiply 2 by itself 1 time or 2 times, right? Directly you jump. So,
So it would be 3.
no, it is not 2 multiply. Okay, it is not 2 multiplied by 1.5 is 3. Okay, but 2 raised to 1.5 is not 3. It is some other value. It is actually, I think it is a bit less than 3. Okay, I mean, if you want to know the value, we can calculate it here. I'll give you in the calculator, you will get it. Yo, what happened?
Less than a minute. Less than a minute in the meeting.
Sorry, what is less than a minute? Okay, let us join back. I'm going to stop the recording. Let us join back. Okay.